For this video, we want to discuss the differences between the definite integral and the indefinite integral. A definite integral will have limits of integration, say a to b of f of x dx. Indefinite integral has no limits of integration, so that's f of x dx. When you have limits of integration, then we know that this is the area under the curve, and therefore it must be some sort of number because it's representing area. So it's a number. And that number, if we can apply the fundamental theorem of calculus, then we know that that's the antiderivative evaluated at b minus the antiderivative evaluated at a. For the indefinite integral, where we no longer have limits of integration, it's no longer the area under the curve, but it's representing the most general antiderivative. And because the fundamental theorem of calculus gives us this nice relationship between integrals and antiderivatives, that's why we use this notation to represent it. So it's the most general antiderivative. So it's no longer a number. Instead, it's a family of functions. Right? Those functions, which are all the possible antiderivatives. So for here, what that looks like is capital F of x plus c, right? Where capital F is any antiderivative. So capital F prime of x equals f of x. And then we add that plus c for the constant. And again, we use that notation because of when we look at the definite integral, again, the capital F here is representing an antiderivative of little f.